Hello, everyone, and welcome to today's QA Wolf conversation. 5 questions to ask about LangChain. How to determine if it's right for your project. I'm your host, Caleb Masters, and over the next 30 or so minutes, I'm thrilled to be diving into this very popular framework of LangChain to determine whether or not it's going to fit your use case by talking a little bit about how QA Wolf established 5 key questions to answer before jumping into it. But before we go any further, I want to welcome the real star of today's presentation. He's our subject matter expert and the Senior Director of AI here at QA Wolf, Nishant Shukla. Nishant, welcome.
Hey, thanks for having me.
Always a pleasure, Nishant. But before we dive into it, I want to give everyone who's tuning in a quick sneak peek at what all we'll be covering today. So first up, we're going to be answering the question, why exactly is LangChain such a popular tool? It's used by a lot of people. So let's actually dive in and break that down for viewers who are kind of trying to learn about the tool themselves. Secondly, we'll talk about the 5 questions that we developed here at QA Wolf to determine whether or not LangChain is going to be a good fit for the use case. And then immediately following each one of those questions, we'll actually do a bit of a case study by applying those questions to the QA Wolf environment. Now, that said, Nishant, let's jump right into our first section here, which is why are people using LangChain? Why is it so popular? It's clearly no secret among developers. It's a powerful tool, but it's hardly the only one. So from your perspective, Nishant, why do developers use LangChain as their preferred framework for building products?
Well, do you remember when ChatGPT came out back in 2022?
Yeah, of course.
Well, that was quite a pivotal moment in a lot of AI development with LLMs. LangChain came out around the same time. And so it has quite the experience, quite the history. It's seen a lot of stuff. You have GPT-4 coming out a couple of months after that, and all these APIs through OpenAI and Anthropic and Cohere, all of a sudden being very useful and impactful for different use cases. So now LangChain is a solution to help you swap models pretty quickly. If you wanted to switch between those API frameworks, now you can pretty easily through LangChain. Another benefit was its nice off-the-shelf tools integrations, for example, with Google Search or weather API uses. You can just find something that is applicable to your needs and try to incorporate it to your code base pretty easily with minor edits in your own code. It kind of just lets you get started. And lastly, the community is awesome. If you're ever stuck, you can end up finding an expert anywhere online that can help you with your specific issues using LangChain.
Right. So in other words, I mean, it's always great when you can look over and say, hey, I have a colleague who's used LangChain, or hey, I'm not sure there's a forum I can go to ask questions about it. And having that resource readily available, I know can be very comforting a lot of the time. Keeping that in mind, though, how did you and the team at QA Wolf determine whether or not LangChain was going to be a fit for the AI that we're building?
You're not going to like my answer because we didn't actually have a systematic 5-question thing that we answered to really figure out whether LangChain is right for us or not. The reason we came up with these 5 questions is now we're finally able to formulate our thoughts and come up with the actual explanation. So we were always asking ourselves, why didn't we use LangChain? And now we can finally explain ourselves.
Right. So sort of like looking back, we can say, hey, we didn't choose LangChain. Why was that? Well, here's the 5 kind of touch points that we recognize in retrospect, which again is why we're sharing this with viewers today. And given the popularity of LangChain, I am super interested in hearing a little bit more about how you arrived at that specific conclusion that you just laid out there. But to get the best understanding, let's jump right into the first of these 5 questions. So question number 1, will the number of prompt templates in your project stay the same over time? So Nishant, how did you and the team arrive at this question?
First, let's just talk about what a prompt template is. So a prompt template is a way to generate new prompts that all have the same structure. And what's different between each of these prompts is the prompt variable. So in this case, you see an example. Tell me a joke about topic. Topic is the variable. That's the thing that changes. It's the name of the variable's topic has different values. If you anticipate the number of prompt templates changing, most likely increasing over time, and you also anticipate the variables changing or increasing over time, then it's a little difficult to use LangChain because of this way that the variables are embedded within the strings. It makes it difficult to maintain as your team grows in size and your code base grows in size. All of a sudden, maintenance is a little challenging and difficult if you were to use LangChain.
Right. So in other words, the more templates you have, the more challenging it's going to be to manage all those different workflows and ultimately the scope of the project consistently. I can imagine if you have lots of different templates, that's actually lots of different possibilities for bugs to pop up. And all of a sudden it turns into a lot more admin work than perhaps you're interested in doing, especially when you're trying to build a new innovative tool quickly. It sounds like
Right.
LangChain might not be the best option there.
Yeah, I just want to make cool stuff. I don't want to maintain all these variables everywhere.
Right. Nobody's got time for that, that's for sure. So I think that leads us right into the QA Wolf response then. How exactly did you and the team answer this question?
Right. In our case, so our system is implemented in this like multi-agent framework where each agent is a prompt and all the prompts talk to each other. So we have many, many prompts, and each prompt has a huge amount of the template variables. So it's and we knew ahead of time that the number of prompt templates will increase over time because that's how we designed the system. We designed it so that it was expansive, so that we can horizontally scale in terms of number of agents, and each agent is an expert at solving a specific problem. So we knew we would just be adding more and more agents over time. So for us, it was kind of a no-brainer that our prompt templates would increase over time. So it made it easy to decide. Retrospectively, that LangChain wouldn't be a good fit.
Right. And I know there were some other optional types, like Python 3, for example. I heard that being discussed. Can you elaborate a little more on your thought process there?
Right, Python, JavaScript, all these programming languages, they have their own way of dealing with variables and strings. In Python, you have f strings. In JavaScript, you have your template literals. So they are just built-in support for concatenating variables with strings. You can use the power of an IDE to refactor. Now, it's a little more difficult to do refactoring if your template variables are embedded in curly braces inside strings. Kind of like it resembles the Jinja syntax for string templates. It's hard to refactor that type of code base when you have many files with many templates and a lot of people editing. You would like to find mistakes in compile time, not in runtime.
Right. So ultimately, it sounds like in our case, we needed a solution that really provided a more manageable way to wrangle the number of templates so that we could be more agile at the end of the day. Uh, Keeping that in mind, let's move on to the next question you and the team developed, which is, will LangChain's monitoring and tracking meet your needs? So, Nishant, how did you and the team determine question number two?
Yeah, it quickly became apparent that if you're already using LangChain, you might as well take advantage of the telemetry offerings, but not the other way around. You wouldn't just go out of your way to use LangChain so you can use the telemetry.
Well, and you say telemetry there. I just want to elaborate before we go any further. What exactly do you mean when you say telemetry, just to make sure we're on the same page?
Yeah, that's a common term and just means it's the process of logging and monitoring the data that's hidden from the user. As an end user, there's certain things that you get to see, but certain things that are hidden from you because they're just the intermediate values or other things that might not be relevant. So in LLM telemetry, we can take advantage of the structure of prompts and specific things related to LLMs like prompt token count and other things that are very specific to the world of LLMs, and that makes it easy to take advantage of that structure to visualize and represent that to an engineer for debugging purposes.
Right. So, I mean, it sounds like at the end of the day, projects that need deeper analysis or highly customized tracking, even LangChain's paid options might not quite provide that same level of control that you need. And with that in mind, I want to take a look and apply this to the QA Wolf environment. Will LangChain's monitoring and tracking meet your needs? Maybe we should start by providing a little more context here, going back to the telemetry piece. I wanted to define that because it's important for people to understand the type of telemetry that we're focused on here at QA Wolf. So Nishant, give me the lowdown here. What exactly is the telemetry data that we're interested in monitoring?
Right. As I mentioned a little earlier, our system is implemented with this concept of agents, and agents interact with the real world to change the state, and then they get called again and again. So when an agent is called multiple times in a row, we call that a session. And what we really care about is the performance of a session. So our telemetry, our analytics, our visualizations of data, our alerting on Slack when something goes wrong is all largely based on the session's health. And each session, we kind of give it a thumbs up or thumbs down. We try to categorize sessions. We try to really understand how a session is implemented through some of the existing telemetry services out there, like LangSmith, which is one of LangChain's offerings for this. You don't really get that out of the box, so you have to kind of implement much of that yourself. So we kind of just opted for using another open source framework. It's called it's a telemetry system for LLMs called Helicone, and it made our life easier. We talked with the Helicone team to help support some of our specific use cases, and we found a happy medium there.
Right. And well, love to hear about the Helicone partnership there. So before we go any further, though, how exactly did you determine whether or not using LangChain was worth that trade-off in terms of time and resources?
Yeah, it was like all about the return on investment. If we were to go through the activation energy of switching to LangChain, do we get that 2 to 5 times return on our own productivity? It was pretty clear that this wouldn't be the case.
Right. So again, it sounds like in this case, the cons of LangChain or the lack of customization, they just weren't worth the time and maintenance it would take to get that detailed data quickly and at a reasonable cost. Which I think is going to take us right on to question number 3. Is limited customization of control flows acceptable? Now, Nishant, I thought that LangChain was known for being highly flexible, so I'd like to get a little more perspective on this question. Why did you include this very fundamental question about LangChain?
Right. So LangChain can do anything. It's a framework in a programming language that lets you just use it for things it's good at and avoid it for things it's bad at. So technically, you could actually do whatever you want in LangChain. It's just that matter of just because you can doesn't mean you should. So in LangChain, it's if you look at the documentation and you look at the README, look at the tutorials, if those are sufficient for your needs, that's awesome. You got lucky. And if you're doing something that's custom, that's a bit different from what the tutorials already show, you might find it a little challenging to fight the API design and the structures. So you might end up writing the same amount of code that you would have if you had just not used LangChain to begin with. Then you get to question, well, what's the point? Why am I using LangChain?
Right. So, I mean, in other words, it sounds like LangChain is flexible for those basic customizations. Again, if you're thinking about paths that maybe others have already been down, you've got some easy flexibility. But if you're looking at something that's highly customized, that has a highly specific use case, especially we're thinking about in terms of large language models, this framework might not cut it for you. With that said, Nishant, hearing your explanation here, I think I'm tracking where we're heading. But I do want to stop and just ask about the terms limited or deep customization, things that we've both said here a moment ago. What is our meaning here at QA Wolf when we say deep customization?
For example, we represent our state in a hierarchical view where instead of, for example, giving the entire HTML at the same time, we want to support the concept of a hierarchical state representation, which lets you view an outline of the HTML and then go deeper into focus on a specific section of the HTML. So this is a concept of hierarchical state representation, which is the way we customize our LM framework that we can take advantage of large inputs. Another example of how we customize is history summarization. So for example, instead of appending the entire conversation history in a trivial way where we just concatenate everything together. We really care about summarizing the history because some of our sessions can last 10 iterations long. Sorry, did I say 10? I meant 100 iterations long. So it can really add up to a giant prompt with a lot of data. And if the HTML content is part of that data, or if you have a massive amount of data, it lowers the quality of the prompt when the prompt is polluted like that. So there's all these things we have to do. I talked about hierarchical state representation, talked about the history summarization, but there's also just this concept of organizing all that information, all the number of variables coming in. For example, the URL of the page, the playwright code, the error message, all of this comes in all at once to the multi-agent system, but we can't give that data to every single prompt each prompt all at once. Each prompt has to be really good at its specific thing. So we employ this like concept of state monad from functional programming that lets us just define each function in a really strongly typed way where the input and outputs are well defined and strongly typed, and then each function can use the knowledge that it lives in a broader context to read and write from this state. It helps us organize the complexity of the just the number of variables we have to deal with.
Right. So again, this is just another example of LangChain not quite hitting the needs that we have here at QA Wolf for building our AI. So with that said, Nishant, let's move on to question number 4, which is your agent architecture static? Now, I know experimentation, of course, is the bedrock of all of the innovation here at QA Wolf, but I also understand that sort of terminology, experimentation, that phase, sounds like the scope can grow pretty quickly. So maybe you could elaborate here for me. Why would someone change their LLM architecture regularly? And maybe what's the thought process behind including this as a question here?
LLMs are a bit new, and figuring out cutting edge AI use cases for designing and implementing LLMs is difficult. You really have to read research papers. You have to follow what's out there and try to re-implement it. And you might end up in many situations where you just rewrite the whole thing and figure out how to do it again in a different way. This diagram here is just an example. Don't look too closely into it. It's just an example of an architecture with databases, inputs and outputs. And you can imagine your own system here, but as you change the databases, as you change the RAG systems, as you change how different components talk to each other, the last thing you want to do is try to be consistent with the idioms of a framework. So that's why, if you're expecting your architecture to change over time, just starting out with LangChain might not be the right approach. It's kind of the other way around. I feel like if you're about to settle with an architecture that you're happy with and you feel like you're going to keep that for a long time, maybe then it's a good idea to consider LangChain, but not initially when you're ready to dynamically experiment with different ideas.
Right. So again, what I'm hearing is LangChain is a powerful framework, especially for established architectures. But if you want to work with more innovative, or I should say cutting edge tools, you're really going to have to invest considerable resources into making it work with the newer frameworks, or maybe the more novel frameworks. Now, with that said, Nishant, I want to actually dissect that thing. I just said, I use the word novel, or we're talking about cutting edge frameworks. That sounds like another potentially subjective way to define a large language model architecture. So how exactly did the QA Wolf team identify and qualify architecture types to experiment with?
Yeah, there's so many good architectures out there. It's hard to figure out which ones to implement. What we do is we look at the common trends of what systems are um, showing high quality performance for similar use cases to ours, and then what do they cite and what do they reuse? What are some common ideas? For example, Tree of Thought is just one of these architectures, but there's so many. There's Voyager. There's some good ideas in OpenDevin and so on that we read and we understand and we see how can we re-implement it to experiment with. Some of our experimentations we just quickly implement and realize it's not the right path, but it lets us fail quickly and iterate and experiment.
Right. And how did you determine whether or not LangChain would support the type of experimentation that we do here at QA Wolf?
It was just intuition. When you're implementing something, it ends up being a question of, should I implement in a framework? Would that speed me up, or would I just directly implement in the programming language of my choice? In our case, it's TypeScript, but we often opted to just go full speed ahead in directly using the API of the LM providers and implementing the designs of the architectures so that we can iterate quickly without needing to think about how it should be implemented in a framework. It frees us up to just moving quickly, and then we can rewrite it in other ways.
Right. And I mean, again, it sounds like, and this is going back to something you said earlier, just because we can do something doesn't necessarily mean that we should. Thinking more specifically about, hey, you could use LangChain in this scenario, but the number of resources and the time it would take in order for you to get the same results would be a pretty significant trade-off there. So again, I'm going to stick with the words of Ian Malcolm here. Just because you can do something definitely doesn't mean you should, especially when you're in this very competitive environment that QA Wolf is working in today. Now, with that said, let's move on to our last question. Is your multi-agent framework simple enough to be managed without complex customization? Now, Nishant, you and I did a whole other video where we talked about the 3 guiding principles behind how QA Wolf built our multi-agent model. But for people who maybe aren't familiar, could you give us a sort of short description? What exactly is a multi-agent framework, and why is it important to consider when thinking about LangChain?
Yeah, a multi-agent system, it's several AI agents working together to solve a bigger problem. Each agent is an expert at a specific thing, and it has its own ability to call some tools or call actions. Actions change the state, so then an agent is called over and over and over again until the session ends and the problem has been solved. So a multi-agent system is just a bunch of agents that pass the baton to each other to solve that bigger problem over time.
All right, well, I appreciate that summary. And again, it sounds like LangChain is probably going to be good at solving for the straightforward actions, maybe of a single agent, but could get a little more challenging when you look at the complexity of a multi-agent model. So let's take and apply that to the QA Wolf environment. So with all of those things taken into consideration, what was the team's thought process when considering LangChain for our multi-agent framework?
Right. When we deal with multi-agent systems, one issue is that the sequence of agents might form a cycle, and so the same agent might be called again. And in LangChain, it's a bit cumbersome to set that up. So that's why there's another library called LangGraph made by the folks who made LangChain. And LangGraph solves some of those limitations of LangChain. But when we look deeper into LangGraph, we realized it kind of didn't mesh well with the way we were thinking about multi-agent systems. We broke down the multi-agent system in terms of 3 levels of abstractions. And we call them L1, L2, L3. L1 is the high-level view. Then L2 is like a zoomed-in view of each node, and an L3 is even more details, even zoom into finer details of specific implementations of the API calls or error messages. So L1 is that high-level graph view of nodes and edges. Each node could be an agent, and how are agents talking to each other. We would like to stick with the distinction between these 3 levels of abstraction, so it would help us communicate, help us document, help us just write our peer reviews in a way that we can collaborate within our team by talking in a language that we've created with this framework. So when we implemented or thought about implementing what we had in LangGraph, we saw leaky abstractions. We saw some items in L2 leak its way up to L1 and vice versa, and it was just a bit of a complicated mess to understand the code because we would like to stick with our different levels. So in this case, if you see the example code in the screen, you see there's a graph, and then the graph, we're adding nodes to it, we're adding edges to it, and then we're also adding a conditional edge to it. Conditional edge is actually a description that the action is not LLM based, and it's kind of a almost like a hard-coded action. So that it's already too much detail. We're beginning to talk about the behavior implementation of the agent, but at this level on L1, we really shouldn't know how behavior is implemented. We should just know that you can have different agents, and they connect to each other in certain topologies, but you don't really care how it's implemented at this point, and you really shouldn't. That's the L2 discussion. And so when we look at code implemented in LangGraph, it's a bit all over the place for us. So yes, you can implement multi-agent systems in LangGraph. In our case, it would most likely slow us down because of the number of agents and complexity and customizations we needed for our case.
Right, and you mentioned the three levels of abstractions. I just want to get some more context here. I mean, when building a multi-agent framework, especially as one is as complex as the one you and the team are working on, why was it important for you to stay on that higher level of the L1 abstraction?
If you stay on the L1 level, you get the freedom to just add more agents to make the problem more solvable. Since we're setting up this concept of each agent is an expert at a specific problem, if we add 10 new agents right into the system, we can freely change the topology of the multi-agent system without worrying about how it's compatible with the implementation of any specific agent. We don't need to read the code or the behavior prompt of any specific agent to understand whether or not it's okay to change the behavior of the agent by adding more agents. So this horizontal scaling lets us add more and more agents without worrying about the inner implementation of any individual agents. Just helps us iterate rapidly.
All right, so I mean, just kind of recapping everything you talked about here with question number 5, it just sounds like at the end of the day, LangChain didn't offer the advantages, the customization, the flexibility that we needed specifically here at QA Wolf. Really to accomplish our ultimate goal, which again, our ultimate goal remains delivering the most effective cutting edge solution to help achieve 80+% test coverage for our customers. And again, I'm very eager to see, Nishant, what you and the team are working on next. I'm sure it's going to be a great innovation. But just to start to wind us down here, how does the large language model framework that you built bring us closer to QA Wolf's ultimate goal?
Right. We would like our QA engineers to gain superpowers. We want them to be able to just do what they do, but much faster. Instead of creating, for example, X number of tests per week, now you should be able to create 10X per week. That's kind of the ultimate goal, is by leveraging the power of the AI system for test maintenance and test creation, you should just be able to do more than you did before. It just gives you that superpower. And that's where we're trying to get at.
All right. Well, I think getting superpowers is a great place to end as well. Nishant, thank you so much for sharing your perspective on LangChain and ultimately why QA Wolf decided not to use the framework. We are out of time for today, unfortunately. Now, before I close out, I did want to share a little more about the multi-agent AI that Nishant's team has been working on and how it's being put to use. So again, for those of you tuning in, QA Wolf's multi-agent AI was built under the principle that humans need to be in the loop to deliver trustworthy and efficient results. Trustworthy results are at the bedrock of everything that we do here in QA. Nishant, thanks so much for joining us. It's been a pleasure.
Of course. Thank you.
All right, and for those of you tuning in, thanks so much for joining us. This has been Caleb and Nishant from the Wolf Den. If you like conversations like these, you can check out our podcast, Wolfed. You can find that wherever your podcasts are found, or head on over to QAWolf.com. Thanks so much for joining us, and have a great day.